unit circle is a really important object in trigonometry as it is the fundamental object for which we define our trigonometric functions. So the unit circle, to begin with, the idea of a unit circle is it's just a circle of radius 1, just like the term unit in math usually refers to one, like one unitary or a unity. Like for example, the imaginary unit is I, which has a length of 1 in that scale, or like a unit length, or anyways, so when you think of the unit circle, that's essentially what it means, just a circle with radius 1, not diameter 1. Could be. So the unit circle, well, we're going to get to why it's important, but to begin with, let's start with its equation, because the equation of the unit circle is very fundamental to trigonometry and how the functions work, and it comes up a lot. So let's start off with that. So uh, the general equation of a circle is on the PowerPoint, as you can see, as x minus h quantity squared plus y minus k quantity squared equal to r squared. Where in that equation, x and y are the two elements of the equation, just like of a line. They're, are dependent independent variables. And then h, k, and r are the respective, the center of the circle is at hk, and the radius is r. So that is a general equation of any circle located at any point in space on a xy graph. So the unit circle, since it's radius 1, we would plug that in on the right-hand side right there, which would leave us with 1 squared, or 1. And then the circle is the unit circle. Well, technically, a unit circle could be centered anywhere, but the unit circle, specifically the one we're going to be working with in trigonometry, is centered at the origin, just for simplicity's sake, at 0, 0. So if we were plugging 0 there, we would get 0, 0, and r would be 1. So that would leave us with the equation x squared plus y squared, because it would be x minus 0 and y minus 0, is equal to 1 squared, or 1, which gives us the fundamental equation of the unit circle. So this equation is pretty simple. Basically, you have a quadratic. It's not a quadratic equation, because a quadratic equation is one where we have x squared only, or y squared only, as we've seen the equation of parabolas. But it turns out that when you square both variables within a numeric math equation, you get a circle. Well, not necessarily, but you would get various conic sections. Not going to get into that right now. Anyways, so the equation of a unit circle is pretty simple, and any point along the unit circle will have to work within this equation. So uh, the unit circle is a collection of points which satisfy this equation. But before we get into that, the unit circle more specifically, why, this is an equation you may or may not remember from algebra. Like, I don't know who would necessarily focus on this specific equation, but I wanted to review, like, well, why does this equation make sense? Because I could just tell you this equation, but it's more important to kind of get, well, why does x minus h squared, etc., why does that make a circle? So really, it stems from the distance formula, because the geometric definition of a circle is a collection of points which are equidistant from the center. Because right, if we have a circle, the point in the center, pretend that's in, uh, is the same distance from each point along the circle. Obviously like a tire, right, and wheels and spokes. And if it's not equidistant everywhere, you got a problem, because it's not round, it's not circular, and it's not going to roll so well. But that being said, what we could view is the distance from the center of the circle to the outside is the same everywhere. It's fixed. So if we take the general distance formula, which looks like this from algebra, I'm sure this is an equation you remember, which to review why that's true, it's true by the Pythagorean theorem, because if we want to figure out the distance between any 2 points um, in Cartesian coordinate space, uh, it's always given by that distance formula, and basically it would be derived from the hypotenuse of a right triangle, where each side is basically, this is how far delta x, how far apart the points are in the x direction, and this leg of the triangle is delta y, how far apart they are in the y direction. And if you take, a squared plus b squared, that must be equal to c squared. So if I wanted to solve c, c is equal to the square root of a squared plus b squared, hence where this formula. And basically, if we're going to be using the individual points at any 2 points, the delta x, the distance of a between points, is given by, just the simple distance, the difference between them case. But anyways, the distance formula gives us the formula for how far apart any 2 points are. But the key with a circle is it's the same distance apart. So what we're going to be doing is fixing d and just calling that r, because in a circle, that's the radius of the circle. Then the circle itself is going to be a collection of points that are equidistant from a specific point. So if we choose to fix x1, y1 to be any random point in space, the remaining part of our equation would be the building blocks for the generic equation of a circle, which has to have a distance from that specific point, the center. So basically, we change that to h, change that to k because it's the center of the circle, and change this to r, which would give us, again, another specific desired thing, which is how far apart it is. Anyways, and then if we were to square both sides there, what that would give us is r squared is equal to the square root would cancel, and it would leave us with that exact equation.